This is SpaceTime Series 27, Episode 47, for broadcast on the 17th of April 2024. Coming up on SpaceTime, new research shows that brown dwarfs are far more star-like than previously thought. Astronomers expecting a nova event before the end of this year. And we look at the extreme Starburst galaxy M82. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that brown dwarfs are created through the same processes as stars and not like planets. Brown dwarfs are failed stars, which don't have enough mass to trigger the core nuclear fusion process, which makes stars like our sun shine. They fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. However, some brown dwarfs start out their lives as red dwarf stars. However, as they age, they burn through so much of their core nuclear fusion material that they lose the mass needed to generate the pressures and temperatures which trigger and maintain nuclear fusion. Consequently, they cease being stars and instead become brown dwarfs. And really, when you think about it, that should have been the first clue. Stars are born through the gravitational collapse of cold, dark molecular gas and dust clouds. On the other hand, planets are formed by the accretion of gas and dust through static electricity into ever larger clumps, which eventually have enough gravity to attract other clumps and become protoplanetary bodies, which then continue to grow through accretion until they clear out their orbits in the protoplanetary disk and become fully fledged planets. The new observations, reported in the monthly notices of the Royal Astronomical Society, show that brown dwarfs are created by the same complex spiral and streamer gas structures as stars. These structures are known as feeding filaments because they feed the gaseous material from the surroundings to the newly born stars, sort of like cosmic umbilical cords. The new observations provide fresh insights into whether the birth of a giant planet takes a similar course to that of a star. Before now, scientists didn't know whether brown dwarfs form in the same way as sun-like stars or not. A test of this hypothesis requires high sensitivity and high angular resolution observations of the brown dwarfs during their earliest formation stages. To accomplish this, the authors used ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, to study an extremely young brown dwarf known as M27E47, located in the northern tip of the constellation Serpent. The study's lead author, Basma Riaz from the University Observatory Munich, says his observations revealed spectacular large-scale spiral and streamer-like structures that have never been seen before heading towards a newly born brown dwarf. The filaments cover a vast area, about 2,000 to 3,000 astronomical units, and are connected directly to M27E47. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres, or 8.3 light minutes, or if you prefer, 8 light minutes and 13 light seconds. Riaz says further clumps of matter were also seen around the object, which themselves could potentially evolve into other young brown dwarfs. These observations show for the first time the influence of the external environment, which results in asymmetric mass accretion via feeding filaments onto a brown dwarf in the making. The spiral structures and streamers provide important clues about how brown dwarfs form. The authors simulated possible scenarios and then compared these with the data from the ALMA Observatory. They found the large structures could be explained by collisions of collapsing clumps within a star-forming region. For this to occur, such collisions would need to have happened at least once during the lifetime of the star-forming core. The author's numerical simulations showed that these collisions would trigger the collapse of even small clumps to form brown dwarfs. Spirals and streamers of various sizes and morphologies form due to the collisions happening sideways and not head-on. Now, if the model's correct, it implies a dynamic brown dwarf formation process, similar to sun-like stars, where chaotic interactions in the star-forming environment are commonplace from an early stage. Now, in another scenario possibility, the simulation showed that the observed structures correspond to the large pseudo-disk around a very young brown dwarf, with the pseudo-disks being twisted by the rotation of the brown dwarf's core in the presence of a strong magnetic field. Now, if this model's correct, it means the magnetic field plays an important role in the brown dwarf's formation process. A comparison of the actual observations with the models supports a gravitational infall scenario, which can explain the asymmetric mass accretion seen in the shape of the spirals and streamers, exactly the same as what's seen around forming stars. This is space-time. Still to come, astronomers expecting a nova event before the end of the year, and we examine the extreme starburst galaxy Messier 82. All that and more still to come on Space-Time. Astronomers are expecting a distant star to explode in a spectacular event called a nova sometime between now and September. The once-in-a-lifetime event involves a type of star known as a white dwarf in a binary system in the constellation Corona Borealis, the Northern Crown, located some 3,000 light-years away. The binary system is normally far too faint to be seen with the unaided eye. But every 80 years or so, the white dwarf pulls off so much material from its nearby companion star, a red giant, that it triggers a spectacular explosion called a nova or new star on the white dwarf's surface. Now, this massive thermonuclear explosion isn't powerful enough to destroy the white dwarf, but it's bright enough to be clearly visible from Earth. In fact, it'll be the third time that humans have witnessed this event from the same star since it was first discovered by Irish astronomer John Birmingham back in 1866, then reappeared in 1946. The study's lead author, Summer Starfield, and yes, that is his real name, from the Arizona State University, says there are only around 10 recurring novae in the Milky Way and surrounding galaxies. He says novae usually explode maybe once every 100,000 years. But recurrent novae repeat their outbursts on human timescales. So what are we talking about here? Well, white dwarfs are the exposed stellar cores of sun-like stars that have run out of fuel. See, a star shines by fusing hydrogen into helium in its core. Eventually, it'll run out of core hydrogen, and so the fusion process stops and the stellar core starts to contract. Now, as it contracts, it causes pressures and temperatures to increase in the core until eventually things get hot and tight enough for fusion to reignite, this time fusing the helium in the core into carbon and oxygen. Now, at the same time, a very thin layer of hydrogen on the outside of the core also begins burning, causing the star's outer gaseous envelope to heat up and expand. Now, because the surface of this bloated stellar envelope is now much further away from the core, it actually gets cooler. That means it turns redder, turning the star into what we call a red giant. Eventually, the star will run out of core helium, and because it's not massive enough to fuse the carbon and oxygen it's made into heavier elements, the star dies. The outer envelope eventually floats away from the core as a spectacular ball of gas and dust called a planetary nebula, leaving the star's white-hot stellar core exposed as a white dwarf, which will be left to slowly cool over the eons. This will be the ultimate fate of our Sun in around 7 billion years from now. However, if the white dwarf is close enough in a binary system to its companion star, it can start to gravitationally suck material from that companion star. This will gradually build up on the surface of the white dwarf until it reaches a critical mass and explodes as a nova. Then the process starts over again. But exactly when it reaches critical mass? Well, that's the $64 question. This is space-time. Still to come, astronomers discover the Starburst galaxy Messier 82 is manufacturing new stars 10 times faster than the Milky Way. And later in the science report, a new study says homosexual behavior may have developed in mammals several times because it plays a crucial role in social bonding. All that and more still to come on Space-Time. Astronomers have discovered that the Starburst galaxy Messier 82 is manufacturing new stars some 10 times faster than the Milky Way. Located 12 million light-years away in the constellation Ursa Major, M82 is relatively compact in size, but has been shown to host a frenzy of star-forming activity. Astronomers made the discovery using NASA's James Webb Space Telescope's near-infrared camera, which they were using to study the galaxy's centre in far greater detail than ever previously possible. The study's lead author, Alberto Bellato from the University of Maryland, says M82's garnered a variety of observations over the years because it can be considered a prototypical starburst galaxy. Starburst simply means the galaxy's making lots and lots of new stars. Star formation continues to maintain a sense of mystery for scientists because it's shrouded by curtains of gas and dust, creating an obstacle for observing the process. Both NASA's Spitzer Space Telescope and the Hubble Space Telescope have previously observed the same galaxy. But it took Webb's infrared abilities to peer through the veil of gas and dust, allowing scientists to study the very centre of the galaxy. The observations, reported in the Astrophysical Journal, show clumpy tendrils extending above and below the galaxy's plane. These gaseous streamers are actually galactic winds rushing out from the core of the galaxy and triggering starburst. One area of focus was understanding how this galactic wind, which is caused by the rapid rate of star formation and subsequent supernova activity, is being launched and influencing the surrounding environment. By resolving the central region of M82, scientists could examine where the wind originates, in the process gaining an insight into how hot and cold components interact within the wind. Webb was able to trace the structure of the galactic wind through its emissions of sooty chemical molecules known as polycyclic aromatic hydrocarbons, or PAHs. PAHs can sort of be considered as very small dust grains that survive in cooler temperatures but are destroyed in hot conditions. Much to the team's surprise, Webb's view of the PAH emissions highlights the galactic wind's fine structure, an aspect previously unknown. The filament emissions extend away from the central region where the heart of the star formation is located. Another unanticipated find was the similar structure between the PAH emissions and that of hot ionized gas. Bellato says it was unexpected to see PAH emissions resemble ionized gas because PAHs are not supposed to live very long when exposed to such strong radiation fields. So perhaps they're being replenished all the time. The discovery challenges theories and shows that further investigation is needed. In fact, Webb's observations of M82 in the near-infrared are spurring further questions about star formation, some of which the authors hope to answer with additional data gathered from another starburst galaxy. Two other papers from the same team, this time characterizing the stellar clusters and correlations among the components of the wind of M82, are now almost ready for publication. In the near future, the authors will also have spectroscopic observations of M82 from Webb available for their analysis, as well as complementary large-scale images of the galaxy and its winds. The spectral data will help astronomers determine accurate ages for the star clusters and provide a sense of timing for how long each phase of star formation lasts in the starburst galaxy environment. This report from NASA TV.
NASA's James Webb Space Telescope has taken a new look at the starburst galaxy Messier 82. This galaxy hosts a lot of star formation activity, sprouting new stars 10 times faster than our own Milky Way. Star formation is hidden by dense curtains of dust and gas, but Webb can see through these murky conditions by peering in infrared light. Webb's near-infrared camera, or NIRCam, pointed toward the starburst galaxy's center to get a better look at a vibrant community of new stars in unprecedented detail. Clumpy red tendrils can be seen extending above and below the galaxy's plane. Dark brown groupings of heavy dust are threaded throughout M82's glowing white core, even in its infrared view. Looking closer toward the center, small green specks represent concentrated areas of iron, most of which are the dense remains of exploded stars called supernova remnants. Small patches that appear red signify regions where molecular hydrogen is being lit up by a nearby young star's radiation. Using Webb to inspect the activity in galaxies like these can deepen astronomers' understanding of the early universe by getting a closer look at the physical conditions that foster the formation of new stars.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims homosexual behavior may have evolved repeatedly in mammals because it plays an important role in social bonding and reducing conflict. The findings, reported in the journal Nature Communications, looked at previous studies and traced the evolution of the behaviors while also looking at relationships with other behaviors. They found that same-sex sexual behaviors are widespread across over 1,500 mammal species, including bonobos, chimpanzees, bighorn sheep, lions, wolves, and wild goats. It's seen in both females and males, and appears to have multiple independent origins, but is most likely to evolve in social species, especially in species that often have adult males killing other adult males. The team suggests that homosexual behavior may have been an adaptation to reduce risks of violent conflicts and maintain positive relationships. Now, these results can't be extended to humans, according to the authors, who say the study only looked at short-term courtships rather than more permanent sexual preferences. A new study has found that 40% of the world's coastlines have seen a significant increase in simultaneous heat waves and extreme sea level rise, especially in tropical regions such as the Pacific Islands. A report in the journal Communications, Earth and Environment claims that under a high emissions scenario, global coastlines could on average experience 38 days of simultaneous heat waves and extreme sea levels each year between 2025 and 2049. That compares to just 7 days per year between 1989 and 2013. Canadian researchers checking up on the TV, computer and video game usage of kids during their teenage years have found a potential link to psychotic experiences. A report in the Journal of the American Medical Association found that teens who played video games a lot and those who increased and then decreased their computer usage during their teenage years were more likely to experience a psychotic episode. The researchers found that this link lessened slightly for video gaming when they adjusted for mental health and interpersonal problems at age 12, but the link didn't change for computer use. Samsung's launched its new 2024 range of TVs, including a new 98-inch mega screen with a mega price range to match. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Yes, well, they've got three different models. The cheapest one is $6,755, their Crystal UHD 4K Smart TV. Then they have a 98-inch QLED model, also 4K. That one's $11,649 Australian dollars. And the most expensive one is the Neo QLED 4K, the QN90D, the top of the range model. It's $15,172 Australian dollars.
Question without notice. It wasn't all that many years ago that we were told that TVs were actually listening to our conversations, so they could report back to their masters what we like to watch on TV. Is that still going on?
As far as I know, it is. Yeah, there are features inside the TV that allow the TV manufacturers to see what it is you're watching, whether it's free-to-air or streaming. And there was talk that Vizio, a brand that's well known in the US, that they were making more money from selling this data than they were from selling the actual TVs. And if you go into the settings of your TV, the smart TV operating system that your computer has, then there's a way of switching off the sending of this information back to the manufacturer, who really shouldn't be spying on you. And in fact, we used to have cameras inside of the TVs, which was very much a Big Brother George Orwell style scenario.
You're kidding.
And well, we don't have cameras inside of our TVs anymore. I mean, you can actually attach a camera to some TVs so that you can do Skype calls. Yeah, but the TVs that used to have that. And in fact, I remember a famous story when former Prime Minister Tony Abbott was visiting China, and they saw that there was a TV there, and they unplugged it and turned it off. Somebody came to the door for room service, and they sort of turned the TV back on. And they realized, hang on, something's not right here. So they actually unplugged the TV and took it outside the room because the TV was being used as a way to listen into the private conversations. At least that was the story.
I can verify that it did happen.
Yeah, well, there you go. And the modern TVs do have these much fancier processors inside, just like your smartphone has a newer processor every year. I mean, the top of the line one in the Samsung TV is the NQ8 AI Gen 3 processor. And this is obviously better than the Gen 2 that I had last year. And there's a lot of these AI features inside a monitor for playing games.
And if 98 inches isn't enough for you, you can go to 110 inches with Hisense.
Yes, now Hisense is another one of the big manufacturers. This one is from China. And they also, on the same day that Samsung launched their TVs, they launched a range of TVs too. Now, most of them are going to come out in May, whereas most of Samsung's are available right now. But they have a 110-inch TV that's coming. Now, the price of that has not yet been announced, but their 85-inch TV is $8,999 Australian dollars. So we don't yet know what this 110-inch TV will be, but their 100-inch TV, which is 2 inches bigger than the Samsung and LG models that are also at this 98-inch size, that's $6,999. And Hisense actually boast of having IMAX certification as well as Dolby Vision IQ and all the other things they have in their flagship models. But one thing of note, Hisense did not mention the word AI anywhere that I can see in its press release. Presumably there are AI technologies in the background to, again, smooth the motion when you're watching sport and improve all sorts of things when you're watching movies. But interestingly, Hisense didn't mention AI, whereas Samsung and LG have mentioned that very much so in their 2024 ranges.
Speaking of AI, Swan has a new home security system that's just loaded with AI.
Yes, Swan is an Australian security company based in Melbourne, but they sell all over the world. And they've got this new AI-driven home shield. They're calling it the future of smart home security, as you would imagine. And they have an AI-driven voice assistant, which actually will answer the door for you when someone pushes the doorbell. And whether it's in an Australian accent or a US accent or a bunch of other accents, will actually appear to be somebody at home answering your questions, telling you where to put packages or just giving you, human-like responses. And it's all driven by the Amazon backend, something called Amazon Bedrock. Now, Amazon has invested $4 billion into a company called Anthropic, who has a system called Claude, which is now version 3. And it's a big competitor to OpenAI's ChatGPT and Google's Gemini. One of the demos that I saw, which was recorded by somebody who was at CES, was talking to this doorbell. He pushed the doorbell and saying, look, I've got a package for you. And his voice, which sounds very human, saying, oh, yeah, we'll just leave it by the front door. I'll come down and get it a bit later. Somebody else said, oh, I want to sell you something. And the voice said, no, look, I'm not in the market for that. Thanks very much.
But this technology has been around for years. Didn't we see it in Ferris Bueller's Day Off?
Who is it?
It's Ed Rooney, Ferris. I'd like to have a word with you.
Oh, I'm sorry. I can't come to the door right now. I'm afraid that in my weakened condition, I could take a nasty spill down the stairs and subject myself to further school absences.
Save it, Ferris. Come down here.
You can reach my parents at their places of business. Thank you for stopping by. I appreciate your concern for my well-being.
I am not leaving till you come down and talk to me, Ferris.
Have a nice day.
You're in big trouble, Buster. Get down here. Ferris. Ferris!
Who is it?
You know goddamn well who it is.
Oh, I'm sorry. I can't come to the door right now.
Well, from memory, he was using a voice recording of himself on a tape recorder. And it was when the doorbell was being pushed, the system was playing a tape recording of him coughing and spluttering and saying that he was sick. And the principal in the movie didn't.
Come on, you loved it too, didn't you?
Oh, no, it was absolutely brilliant. There's no question about that. But these days, AI can convincingly simulate a human. And the whole idea of this system is that it's going to make somebody think that there's somebody at home.
That's Alex Zaharov-Reut from Tech Advice. Start Live. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.